Hi there, welcome to the Trig exam questions. I'm going to take you through just a variety of Trig questions in this video and everything higher apart from wave function. Okay, so looking here, we're solving the equation. First thing to notice is that we have two different trig terms, cos 2x and cos x, one with a double angle. Okay, so we've got a 2x here and an x here. Now, we know when we've got a double angle within an equation, we're going to substitute in and factorise. With the cos 2x, we've got three options: cos squared minus sine squared, 2 cos squared minus 1, or 1 minus 2 sine squared. We want to use one that only has cos in it because we've got another cos here. So this is going to become 3, then 2 cos squared x minus 1 plus cos x is equal to -1. Okay, when you break these brackets, that's 6 cos squared x minus 3 plus cos x is equal to -1, which becomes 6 cos squared x plus cos x minus 2 when you set it to 0 so you can factorise it. There is no common factor, so it's going to be a trinomial, and that trinomial is going to be 3 cos x plus 2, and then 2 cos x minus 1 is equal to 0. Okay, and as we've been doing since National 5, this bracket set to 0 is going to give us cos x equals -2/3, and this bracket set to 0 is going to give us a half. Okay, so the cast diagrams for solving the left-hand strand is working in the negative quadrants for cos, so S and T. The inverse of 2/3 is 48.2. So my solutions are 180 take away 48.2, so 131.8 degrees, and 100 add 48.2, so 228.2. Same thing for this strand, we're working with a cos that's positive this time, so we're in quadrants 1 and 4, and we know the inverse cos of a half is equal to 60 degrees. So my solutions here for this strand is 60 degrees in the first quadrant, and in the fourth quadrant 300 degrees. Okay, so let's look at marking. 5 marks for this question, might be a bit generous these days, but the first mark is for you substituting in the correct cos term. Second mark for setting to 0 so you can factorise. The third mark for factorising, and then the fourth mark and the fifth mark for each strand there. Okay, doke. So moving on to question 2, we're looking at solving 2 sine 3x minus 1 is equal to 0. Okay, and I'd asked you in the homework to do this between 0 and pi rather than 0 and 180, just to get some practice with radians. Okay, now we're noticing here there is only one trig term, just one sine function, so all we're going to do is cancel out things, isolate the x and find out what it is. Okay, so the first thing that's going to go is that plus 1, so it's 2 sine 3x is equal to 1, which means sine 3x is equal to 1 over 2. Okay, next we are going to get rid of that sign by doing the inverse sign. It's equal to positive a half, so we're working in the first two quadrants. So we're doing inverse sine of a half, which we know is 30 degrees, or in radians, pi over 6. Okay, so in getting rid of the sign, we will be left with 3x. So that means 3x is equal to pi over 6, or in the second quadrant, it'll be pi take away pi over 6, which is 5 pi over 6. And then dividing by 3 to isolate the x, we've got an extra factor of 3 in the denominator now, so it's pi over 18 and 5 pi over 18. So that is, you've got your first two solutions for this problem. Now, we know that for a sine 3x wave, we have 3 waves in 360 or 2 pi, which means one wave is in 120 or 2 pi over 3. Okay, which means your two solutions that we found here are going to repeat 120 degrees later on. Okay, and then 120 degrees later on again. Okay, now when you have these two solutions, that means you have to add on 120 or 2 pi over 3 each time to find your next solutions. Okay, now for more rough working here, pi over 18 add 2 pi over 3 really means pi over 18, and multiplying numerator and denominator by 6 to get 18 is going to be 12 pi over 18. So really, every time you're adding on 2 pi over 3, you're really adding on 12 pi on the numerator. So that first one will be 13 pi over 18. Okay, the second one there, your 5 pi over 18, is going to become 17 pi over 18 because you're adding on that 12 pi on the top. Okay, and then same again, that 13 pi over 18, add another 12 pi over 18. It will be 25 pi over 18. And then 17 pi over 18, add another 12 pi over 18 on the top is going to be 29 pi over 18. Okay, you could add on again, 25 pi over 18, add another 12 pi over 18 is going to get you up to 37 pi over 18, which is above a single pi. In fact, as are these two. These two are above a single pi as well, so they're not going to be part of your solution. Okay, so now that's you. Let's have a look at the marking. Okay, so first mark is we're getting sine 3x equal to 1 pi. Second mark is for getting 3x equal to pi over 6 and 5 pi over 6. Your third mark is then getting the solutions, these two solutions here, and then your fourth mark is for getting the finalized solutions across all the way up to a pi. Okay, number 3, again solving an equation. Again, we are looking at two different trig functions, one with a double angle. So we know we're substituting in one of our expansions from the formula sheet, and we're going to factorize. Sine 2x only has one option. It's 2 sine x cos x. So that's what we're substituting in. And then when we're factorizing, the only thing we can do here is take out a common factor of sine x. So you're left with sine x and you're left with 2 cos x plus 1. So two options here, either this factor, sine x is equal to 0, or this factor, 2 cos x plus 1 is equal to 0, which leads us to cos x equals negative a half. Okay, for sine x equals 0, we can get those solutions from a graph. We know the three solutions there are 0, 180 and 360, but our range means it has to be strictly less than 360. So x here is only going to be 0 and 180. If that was less than or equal to, your 360 would have to be included. For the right hand strand here from my cos, my cast diagram, negative cos, so quadrants 2 and 3, inverse cos of a half, we know is 60. So my solutions for that second strand are 60 and not 300. Actually, they're both wrong, apologies. Okay, and the second quadrant is going to be 180 take away 60, which is 120, and the third quadrant is going to be 180 plus 60, which is 240. Okay, now, okay, it's saying 5 marks. I totally disagree with that. I think it has to be 4 marks. One for the substitution, one for the factorization, and then 1 mark for each strand of solution. Okay. So next question here. Now this is a lovely question. Part A, show that 2 cos 2x minus cos squared x is equal to 1 minus 3 sine squared x. Okay, so we are trying to show that this is equal to this. So we're going to start with that left-hand side. We're going to do some maths, and then we should end up with the right-hand side to prove that it can equal the same thing. So looking at these values here, what can we do? Well, we know that cos 2x can be expanded. Okay, the three options, cos squared minus sine squared, 2 cos squared minus 1, or 1 minus 1 minus 2 sine squared. Now, because this is where we're trying to get to here with sine squared, let's use the 1 minus 2 sine squared x value for that cos 2x. Now, when you expand that, that gives you 2 minus 4 sine squared x minus cos squared x. Okay, so we're getting closer. This looks an awful lot like this, but this minus cos squared x is a problem. Okay, so we need to substitute something in here. Now we know from National 5 that sine squared x plus cos squared x is equal to 1. So we want to take out cos squared x and we want to put in stuff with sine squared x. So rearranging that, cos squared x is going to be 1 minus sine squared x. And then when you substitute that in there, 2 minus 4 sine squared x, take away all of that, careful to put it in brackets. That's going to give you 2 minus 4 sine squared x minus 1. And then when you multiply that negative by the negative inside, it's going to be plus sine squared x, which is 1 minus 3 sine squared x, which is the right hand side of the proof that we are looking for. Okay, so that is us done. Okay, now for part B, hence solve the equation. So 2 cos 2x minus cos squared x is equal to 2 sine x. Well, actually, we know that this 2 cos 2x minus cos squared x, we will use that in the first half of the question. And this word hence tells us use what you've just done. Okay, so that there, we know really means now 1 minus 3 sine squared x is equal to 2 sine x. And that's an equation to solve. Now you have a trig equation, but you also have a quadratic equation because you've got a squared term in there. So I'm going to get everything to the right hand side so that I can factorize it. So it'll end up being 3 sine squared x plus 2 sine x minus 1 is equal to 0. Okay, so no common factor, so it's going to be a trinomial. 3 sine x and sine x. Okay, plus 1 and minus 1 there. Okay, and then solving both strands. That first strand will give you sine x is equal to a third. That second strand will give you sine x is equal to negative 1. Okay, dealing with that one first, we know from our sine graph that actually is equal to negative 1 at 270 degrees. And for this one here, sine x equal to a third is positive, so working in first two quadrants. The inverse sine of a third is equal to 19.5. So your two solutions there are 19.5 in your first quadrant, and in your second quadrant 180 take away 19.5, so that's 160.5. Okay, looking at marks. Okay, in part A, you're getting 1 mark for substituting in the double angle for cos, and then 1 mark for substituting in for cos squared x, and then leading to the answer. Okay, in part B, you're getting 1 mark for substituting in the thing from part A, 1 mark for factorizing, and then 1 mark for each strand being solved. Okay, next question. Okay, again, we're still solving equations. Really want to hammer on that just in terms of getting used to it. We only have one trig function, so it's a case of isolating the x, working your way towards it. So the first thing that's going to go here is your 2 at the front. So it's sine 2x minus pi over 6 is equal to a half. Okay, we're working in radians here. Next thing to go will be the sine. So sine is equal to positive a half. So first two quadrants, we know the inverse of a half is equal to 30 or pi over 6. So when this sign cancels, you're left with that bracket. So 2x minus pi over 6 will be equal to pi over 6 in the first quadrant, and pi take away pi over 6, so 5 pi over 6 in the second quadrant. We're still working our way to x, so pi over 6 is going to go next. So first is pi over 6 and pi over 6 is 2 pi over 6, or simplifying it, pi over 3. And then 5 pi add pi over 6 is going to take you back to just pi. Okay, so x then dividing by 2 gives you an extra factor of 2 on your denominator, so pi over 6 and then pi over 2. And we want all our solutions between 0 and 2 pi, so we know between 0 and 2 pi for a sine 2x wave, we have two waves. The period is 180 or a single pi. So these two solutions are going to be replicated 180 degrees later on, or adding pi each time. So pi over 6 add pi really means you're adding 6 pi over 6. So that one's going to be 7 pi over 6. And pi over 2 add pi means you're adding 2 pi over 2, which gets you 3 pi over 2. Now if you're to go the same again, add another 6 pi on, you would get to 13 pi over 6, which is over 2 wholes, or 2 whole pi's. So that's your solution there. Okay, for marking, your first one is for your strategy of getting the first thing equal to a half. Your second is for getting your first solutions to 2x minus pi over 6. Your third mark is for getting these first two solutions, so going from this line down to the bottom. And then your fourth mark is for adding on and getting all the solutions in your 0 to 2 pi range. Okay, again, part A, solving an equation. We've got one trig function and then we've got another. There's a double angle involved. So sine 2x has to get swapped in for 2 sine x cos x, and then you're factorizing to solve your equation. Okay, the common factor here is cos x. So each strand cos x equals 0, or 2 sine x minus 1 is equal to 0. For cos x being equal to 0, we know from our cos graph that's 90 and 270. So your solutions there are 90. One, I don't need 270 because that's 0 and 180. And then sine x equals a half. We're going to work in quadrants, first two quadrants, and we know inverse sine of a half is just 30. Halves are very popular one here today. So 30 from your first quadrant, 150 from your second quadrant. Okay, so there's your three answers between 0 and 180. And for part B, use your solutions in A to write down the coordinate of point P. Well, first thing we're looking at is point P is a point of intersection between these two graphs, sine 2x and cos x. So when we make them equal to each other and go to solve them, what you need to notice is actually we've already solved this equation. We solved it here. So my three solutions are 30, 90, and 150. So that point there, that point of intersection must be 30. 90 is my second point of intersection, and that one's got to be 150. So the x coordinate of P is 150. Okay, it wants the full coordinates of P. So y is just going to be either one of these things here, cos x or sine 2x, but with 150. So cos 150, and let's presume it's without a calculator here. Cos 150 is in that second quadrant, so it has to be negative, and it's going to be negative cos. We know that one's going to be 180, take away a gives me 150, so the related angle has to be 30. So it's minus root 3 over 2. So the coordinate is 150 minus root 3 over 2. Right, I'm sure you're getting the hang of this. Your first mark in part A is for subbing in, your second mark is for factorizing, and then your third mark is for each strand of solution. And then part B is just one mark for your coordinate at the end. Okay, changing it up slightly, at least for part A. So for part A, f of g of x. Okay, so f of g of x, we're putting g of x into f of x. So it's going to be f of g of x, which is 2x. So that means this 2x is going to replace the x in f of x. So that really means sine of 2x. Same thing for part 2. Apart from the other way around, g of f of x means we are putting sine x into f of x. So that sine x is going to go into g of x, sorry. So sine of x is going to go replace this x. So that's just going to become 2 sine x. And part B, we need to solve 2 f of g of x equals g of f of x. So that really means 2 lots of sine 2x is equal to 2 sine x. Okay, you're solving that. Now again, 2 different trig functions, one with a double angle. So substitute in and then set it to 0 to factorize. So we'll subtract 2 sine x from both sides. So that's 4 sine x cos x minus 2 sine x equals 0. You have a common factor there. So 2 sine x comes out, and then you're left with 2 cos x minus 1 inside your bracket. So that means either sine x is 0 or cos x is equal to a half. Sine x is 0, that's 3.0180 and 360. You can see the range includes 360 because it's equal to. So your 3 solutions from there are 0, 180, 360. From here, cos x equals positive a half. You're in quadrants 1 and 4. Inverse cos of a half is equal to 60. So x is going to be quadrant 1, 60, quadrant 4, 300. Okay, marking. Just one for each correct answer in part A. The first mark is for actually using and setting it up from that function given there, or those functions given there. The second is for subbing, third for factorizing, fourth and fifth for solving each strand successfully. Okay, so given that tan alpha is equal to root 11 over 3, find the exact value of sine 2 alpha. Okay, so noting there's no equations here. We could maybe solve that if we were asked, but we're not. We're asked to find the exact value of sine 2 alpha. Now, I know that sine 2 alpha, particularly if I've only got information about alpha, I want to use my double angle formula. I want to get it so that I only have single alphas rather than double alphas. Okay, because that's the information I've got here. The problem now is the information I've got is about tan, not sine or cos. But because this tan is equal to a fraction, it's nice and easy to turn that into a right angled triangle. Okay, so tan alpha is equal to root 11 over 3. We also know that tan is equal to opposite over adjacent. So if we call that angle alpha, the opposite has to be root 11 and the adjacent has to be 3. Okay, that hypotenuse is just going to come from Pythagoras. Root 11 squared is just 11, 3 squared is 9. So that hypotenuse is root 20, which means I can find out sine alpha as opposite over hypotenuse. So root 11 over root 20. And cos alpha as adjacent over hypotenuse, which means 3 over root 20. And that changes this here into 2 times sine alpha, which is root 11 over root 20, times cos alpha, which is, not root 3, just 3 over root 20. And then you can simplify out. Numerators give you 6 root 11, denominators give you 20, so that really means 3 root 11 over 10. Okay, so marking 1 is for your triangle, including the root 20. The second is for subbing in from the expansion. And your third is for getting to your answer. Okay. Now, same again here, we're looking for, we've not got an equation to solve, but we're trying to show the exact value of sine p plus q is 63 over 65. Okay, now sine p plus q We know because trig functions aren't linear, we need to expand the brackets fully using our expansion. Turns into sine p cos q plus cos p sine q. Now, we have values for two of these, sine p and sine q. But similar to the last question, we can use those fractions. Sine p is 12 over 13, so the opposite is 12, the hypotenuse is 13, which from Pythagoras means your adjacent is 5. And sine q is 3 over 5, so the opposite is 3, the hypotenuse is 5, which means your adjacent is 4. And that means we can get our values for cos p and cos q as well. So cos p is adjacent over hypotenuse, cos q also adjacent over hypotenuse. So sine p is 12 over 13, cos q is 4/5, and then we're adding on cos p, which is 5 over 13, sine q, which is 3/5. And then that's 48 over 65, that's 15 over 65, so that gives you 63 over 65. Okay, marks for that, 1 for your triangles, 1 for your expansion, and then 1 for subbing in and getting to the answer. Okay, so 1 for your triangles, 1 for expanding, and then 1 for correct substitution, and then on for your answer. Okay, exact value of sine theta plus 120 cos theta plus 150. Okay, so again, no equation, just given something to find the exact value of. Now, there is no exact value to find in this form because we don't know anything about the thetas. Okay, but what we can do, looking at this question, is right, well, sine theta is just sine theta. But these are expansions from a formula sheet using the addition formula. So this sine theta plus 120 really turns into sine theta cos 120 plus cos theta sine 120. And then similarly, the cos theta plus 150 turns into cos theta cos 150. Subtract sine theta sine 150. Okay, so that's my first step, is expanding those brackets. Now in here, the only things I can work with, the thetas I don't know what they are, but I do know what cos 120 is, or I can figure it out. And the same with sine 120, cos 150, and sine 150. Okay, so looking at this, cos 120, using my cast diagram, 120 is in that second quadrant, so I know I'm going to be dealing with a negative cos. I also know that in that second quadrant is 180 take away a, so to get to 120, I need to take away 60. So cos 120 is the same as negative cos 60, which really means negative a half. So that sine theta at the start is still sine theta. This though is now minus a half sine theta, because that cos 120 has been replaced by negative a half. Looking at the next one, sine 120. Well, 120 is still in that second quadrant. In the second quadrant, no sine is positive, but it's still equivalent to 60. And sine 60 is root 3 over 2. So that next one becomes plus root 3 over 2 cos theta, because that sine 120 has been replaced by root 3 over 2. Carrying on, cos 150. Okay, we're still in that second quadrant, so I'm still dealing with a negative cos. And to get from 180 minus a to 150, I need to take away 30. So it's negative cos 30, which is negative root 3 over 2. Which means there, my next one is now negative root 3 over 2 cos theta, because this cos 150 has been replaced by negative root 3 over 2. And then finally, run out of space, I'll just bring it out here. Sine 150, we're still in that second quadrant, where sine is still positive, and it's equivalent to sine 30, which is a half. So that last one here becomes minus, because it's a minus, a half sine theta. because that sine 150 gets replaced by a half. Now, let's have a look, see if we can do anything else, because we don't have an exact value yet. First thing to note is in the middle there, that root 3 over 2 cos theta take away root 3 over 2 cos theta, they're going to cancel. And then sine theta take away half sine theta take away half sine theta means that we've got sine theta and then we're taking away a whole sine theta. So actually we're left with nothing at all because these all cancel as well. So marks here. First one is for expanding correctly. The second one is for subbing in your exact values correctly. And your third one is for them evaluating and getting 0. Right, 2 questions to go. First one here. On the coordinate diagram shown, A is 0.68 and B is a 0.12 minus 5. Find the exact value of sine P plus Q. Okay, now I don't have the value for P plus Q or sine P plus Q, so I need to use my expansion. From the formula sheet, that means that this is sine P cos Q plus cos P sine Q. Right now I don't have values for any of that. I don't have my triangles. I don't have tan values for tan, cos or sine, so I can't get my triangles. But these coordinates here means that to get to A you go 6 across and 8 up. So that triangle there involving P is going to be 6 across and 8 up. And when you do Pythagoras, that gives you 10 as your value there. Okay, on that other triangle, for Q, it's 12 minus 5. So looking just at the size of that, that means that's 12. This is, well, not negative 5 because it's just a triangle, it'll just be 5, which makes your hypotenuse 13. And that means you can go back to this this expansion and fill in the values. Sine P, opposite over hypotenuse, 8 over 10. Cos Q, adjacent over hypotenuse, 12 over 13. Plus cos P, which is adjacent over hypotenuse, which is 6 over 10. And sine Q, opposite over hypotenuse, which is 5 over 13. Sorry, 5 over 13, not 5 over 12. Okay, and then just simplify. Okay, this comes into 48 over 65 plus 15 over 65, which again is 63 over 65. Okay, very similar question to earlier on, obviously, but a different concept. This one's also a bit more generous with the marks. I would give 1 mark for your triangles being correct, 1 mark for the expansion, 1 mark for substitution, and 1 mark for simplifying. But I think that is quite a generous mark question again. Okay, and last one, functions, blah, 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 blah. Find expressions for f of h of x and g of f of x, g of h of x, sorry. Okay, so similar to one we completed earlier on, part A, f of h of x, we are putting h of x inside f of x, so that means that h of x is going to be put in here instead of x, so it's going to be sine x plus pi over 4. Okay, for part 2, g of h of x means you're now putting h of x inside g of x, so this is going to go in here instead of the x, so it's cos x plus pi over 4. Okay, for b part 1, we have to show that f of h of x, so that first expression we did, is equal to 1 over root 2 sine x plus 1 over root 2 cos x. So f of h of x equal to sine x plus pi over 4, which we know we can expand to sine x cos pi over 4 plus cos x sine pi over 4. Okay, and looking at that there, we know the values for cos pi over 4 and sine pi over 4. Pi over 4 really means 45, and for both cos and sine, that's 1 over root 2. So it's 1 over root 2 sine x on it. 1 over root 2 sine x plus 1 over root 2 cos x, hence shown. Okay, for part 2, maybe try and use all the space I've got here. Find a similar expression for g of h of x. So that's equal to g of x was cos of x plus pi over 4. So similar idea, cos x cos pi over 4. Subtract sine x sine pi over 4. And then just subbing them in as 1 over root 2 cos x, subtract 1 over root 2 sine x. Okay, and then solve f of h of x. Okay, so then solve f of h of x, subtract g of h of x is equal to 1. Okay, so f of h of x is 1 over root 2 sine x plus 1 over root 2 cos x. Take away all of g of x, which is 1 over root 2 cos x minus 1 over root 2 sine x, and all of that has to be equal to 1. Okay, and I'm just going to skip a step here, but in there, when you break this bracket, that's 1 over root 2 cos x, take away 1 over root 2 cos x. So they're gone, they cancel out. And when you do negative times that negative in here, that's going to be add 1 over root 2 sine x. So you're going to have 2 over root 2 sine x is equal to 1. And that's what you're really solving. Okay, now when you times by root 2 on both sides and divide by 2, sine x is going to be root 2 over 2, which is, when you do inverse sine, root 2 over 2 is just a rationalised 1 over root 2 in those quadrants 1 and 2. Inverse sine is 45 or pi over 4. So my solutions are x in quadrant 1 is pi over 4, and in quadrant 2 is 3 pi over 4. Right, and for the last time, marks, 1 mark in each of the part 1s. For B part 2, you're going to get 1 mark first of all for the expansion, and the second mark for calculating it. Your third mark is then for doing the both things for the same for g of h of x. 1 for subbing in, and then the 5th one for solving. Okay, so a bit stingy later on, but that's what you've got. Okay, so as I say, a lot of those questions are similar, but you need to just get used to solving equations and using your expansions. That's a kind of big thing with trig. It can pop into, obviously, it can pop into differentiation, integration, and we'll look at the wave function separately. But these are the things we're looking at in terms of being comfortable with the trig topic. Okay, thanks for your time.